talk about significant figures, sometimes referred to as significant digits, or sometimes just abbreviated down to Sig Fig. I guess I'm pluralizing it. Significant figures or digits is about describing the precision of a measurement. So in math class, we have two numbers here, 3.0 and 3, and the question is, do they mean the same thing? Well, in math class, they are true. This is math. In science, not necessarily. So I'm just going to say they're not equal. There are some situations where they are and some situations where they're not, but we cannot assume. Don't assume. Because they actually mean something slightly different. And this is what I mean by the precision of the measurement. This is telling me that there's no reason to write that 0 there. There's absolutely no reason to write that 0 unless it has some importance here. And so that 0 right there to the right of the decimal, that's the 10th place. This tells me that this number right here represents an actual measurement of anywhere from 2.95 to 3.05. Whereas this one, without that, is telling me that this represents anywhere from 2.5 to 3.5. So this has been rounded off to the nearest ones, and this is now rounded off to the nearest tenths. When we talk about significant digits, we're talking about the number of digits which actually have some important meaning in the expression. So here I have 2 digits here, so this is 2 sig figs. This is only 1 digit, so that's 1 significant figure. Now, there are a couple other things here. We have things called trailing zeros. This is a trailing 0 because as we go from left to right, it comes at the end. There are also leading zeros, so 0, 3.0. This 0 here does have importance. It's telling you where you rounded off. This 0 right here has absolutely no meaning. This is known as a leading 0, so this is leading and trailing. This doesn't tell us anything at all other than the fact that we like to write a 0 there. So this still is 2 significant figures because that is not significant. Now, if I have a measurement that's 3.0 centimeters and I want to convert it into meters, well, centimeters to meters is you'll move the decimal point over 2 places. So this becomes 0.030 meters. This is still, these have significance here, but that 0 right there just is showing up because all I did was change my units. So changing units does not change the amount of significance. And so this is still 2 significant figures. Those 2, this is not significant. Because I can always put this into scientific notation, and I'm back to 3.0 times 10 to the negative 2 meters, still 2 significant digits. So we have a certain number of rules here. 1, any non-zero digit is significant. 2, so that would be the numbers 1 through 9. Any digit between 2 significant digits is significant. So if I have the number 506, that 0 is significance because it's between 2 digits that are significant. So this would be 3 sig fig. 3. Leading zeros. Are not significant. So 0.506 is still 3 significant figures because the leading 0 doesn't count, or 0.0506, that 0 is still not significant because it's leading. 4. Trailing zeros to right of decimal are significant. Trailing zeros to left of decimal, I'm going to say decimal place. If the decimal actually shows up, it suddenly becomes significant, but to the left of the decimal are not significant. And what I mean by decimal place, if I have the number 500, 500 is 1 significant digit. These are trailing zeros. They're to the left of the decimal point, which is the decimal place, not the point itself. Now, if I was say I had 500 books in the house, then is that 500 exact or is that a rough estimate? Well, if I'm expressing it like this, 500, then I'm saying I have between 450 and 550 books. Now, if it is 500 exactly, how do I express that? Well, I can do it a couple ways here, but one of the ways is just to put a decimal point there. So this is trailing zeros to the left of the decimal place are not significant unless the decimal point appears. Or the other way of expressing this is to underline that last bit of significance. So this would be anywhere from 499.5 to 500.5. If I did 500 and underline that one right there, this is between 495 and 505. And then if I just write 500, we're back to that a little bit fuzzier. So unless the decimal point appears or a digit is underlined. So those are the basic rules right there. So let's just do a couple practice runs here. How many significant digits? Well, that would be 3. How many significant digits? Still 3. Still 3. Four. This is significant. It's a trailing 0 to the right of the decimal point. That's 4. So this would be number of Sig Fig. These are all significant right here because they're not 0, and that is between two significant digits, and so there would have 5 total. This has 6 significant digits. And 0.005. This would have 3 significant digits because these are leading zeros, and leading zeros don't count. All right. All right, so there is one other bit of significance, and this is infinite significance. So let's say that I have a square. And so this is 4 meters, 4 meters, 4 meters, and let's take it out more, 4.00 meters, 4.00 meters. And I asked, what is the perimeter? So the total distance around. Well, the perimeter is 4 times the length of a side, so this is 4 times 4.00. Well, that 4 right there has infinite significance. Now this comes from a measurement itself, so this has 3 significant figures, but this 4 is because I have 4 sides here. If it's a square, it's got 4 sides. It's not going to have 4.1 sides or 4.05 sides. This is not rounded off. This is an exact number. And so this is exact, and so significance is infinite. So I guess we can now do Rule 5. An exact number has infinite significance. And so exact numbers show up when you're, say, the example I just did with the perimeter. It also shows up when you're doing unit conversions, because many times when you're converting from one unit to another, there is an exact conversion. So, for instance, it's exactly 2.54 centimeters in an inch. That is 2.54 exact. That has infinite significance. Not just the 3, because you write down 3 digits.